calculating the second moment of inertia and section modulus for thin-walled and closed profiles is slightly different compared to the ones how we calculated that for thin-walled open profiles. The formulas that we're going to use for calculating the shear stress and the twist are still the same, but what we need to calculate differently are the second moment of inertia and the section modulus. So in this image we have a cross section that is a rectangular shape, and the wall thicknesses are a bit different across the different walls, but in here we have the equation how we calculate the Ix, second moment of inertia. Well, first thing that we have done here is that we have drawn the imaginary center line, just like we did before for the open profiles. So we must draw first the imaginary center line, which is this dashed line that you can see in here. In the formula for second moment of inertia, we have new term A, which we need to define in order to calculate the second moment of inertia. This A, as we know, big letter A typically refers to cross-section area, and it's the case also in here. But this cross-section area is not the entire cross-section area of the profile. It is not the cross-section area of the hole inside. Instead, this is the cross-section area calculated from this imaginary center line of this profile. In this case, for example, it is 96 millimeters, which is the length from here to here, multiplied by 51.5, which is the length from here to here. That is our A in this case. This is then divided by the sum of the lengths of the imaginary cross sections, rectangles, divided by the thickness of each of those sections. Let's take an example. Here we have 96. 96 is 100 millimeters minus 2.5 minus 1.5. So that is 96 divided by 3, which is this thickness in here. Same thing, 51.5 divided by 5. The 51.5 is the length from here to here, divided by the thickness of that section. And same thing for the rest of the sides. And finally, when we calculate that, we get the second moment of inertia. In case of thin-walled closed profiles, we don't need to first calculate the second moment of inertia in order to calculate the section modulus. The section modulus on closed profiles is calculated by this equation down here. This equation works so that you have 2 times the cross-section area of the imaginary center lines multiplied by the minimum thickness of the given profile. To further highlight what is meant with the A, I will draw here a bit of lines. So the cross-section area A will be this area in here. So that is the cross-section area A in this example. So with these simple formulas, you're capable of calculating the second moment of inertia and the section modulus of thin-walled closed profiles.